perpendicular lines. Consider these figures: a table, a book, and the English alphabet L. All these figures have two intersecting lines. Note that the angle between these intersecting lines is 90 degrees. Such lines are called perpendicular lines. Therefore, the angle formed between two intersecting lines is a straight angle. Then the lines are said to be perpendicular lines. This is the symbol we use for perpendicular lines. Now if a line segment AB is perpendicular to CD, it also means that CD is perpendicular to AB. Now consider a line segment CD. Mark the midpoint of CD as E. Now take a line segment AB which is perpendicular to CD and passes through E. This line segment AB bisects CD at E, which is the midpoint of CD. So we call AB as the perpendicular bisector of CD. Hence, if a line segment AB is perpendicular to another line segment CD, divides it into two equal parts, then AB is called the perpendicular bisector of CD.
Perpendicular lines. Look at these two lines. AB intersects CD. The point of intersection of the two lines is O. The four angles formed at the point of intersection are 90 degrees each. Therefore, the two lines are said to be perpendicular to each other. If O is also the midpoint of CD, then AB bisects CD because it divides CD into two equal halves. Such a line which intersects another line at right angles and divides it into two equal halves is known as the perpendicular bisector of that line.
Children, listen here. One question. Study the diagram. The line L is perpendicular to line M. So here this is the line L. Okay. And this is the line M. Okay. Perpendicular to line M. Okay. So here is line L is perpendicular to line M. So here is perpendicular. Here the angle is right angle or 90 degree. Okay. So here first question, a question, is CE equal to EG? So CE, so here CE, CE is this point. Okay. C to E, how many units? C to E is C to D 1 unit, D to E another 1 unit. So C to E plus 1 is 2 units. Okay. CE equals 2 units. Okay. Like that, EG, E to F 1 unit is E to G is 2 units. EG equal to 2 units. Okay. CE equal to 2 units, EG equal to 2 units. Is CE equal to EG is the question. Yes, answer is yes. Okay, hope all of you understood. Then next B question. Does PE bisect CG? PE, see here, this is the PE. Okay, bisect CG. Okay, bisect means is divide it into equal halves. So C to E how many units? Is 2 units. E to G is again 2 units. So CE and EG are 2 equal halves. Okay. So here is PE bisect CG. PE bisect CG. All of you understood? Okay. Then C question. Identify any two line segments for which PE is the perpendicular bisector. So perpendicular bisector means is the line is perpendicular also, then bisector also. Bisector means divide it into equal halves and the angle formed there is 90 degree or a right angle. Okay. So identify any two line segments for which PE PE is the perpendicular bisector. So here one is one line segment CG. Okay, CG is the perpendicular bisector of PE. Why? Yes, PE bisect CG. Okay. So and also the angle formed here is 90 degree or right angle. So is one line segment is CG. Okay, two line segments. So first one CG, then in one more. Okay, PE bisect, then another D2E. D2E is 1 unit. E2F is again 1 unit. So DF is also a line segment. Identify any two line segments for which. Okay, so you can take DF, then here B2E, how much? B2E is 1 unit, 2 unit, 3 units. Okay, then E2F, how much? 1 unit. It's E2G, 2 unit, E2H, yes, 3 units. So BH is also a line segment. Okay, B2H. So BH, B2E is 3 units, E2H 3 units. So BH is also a line segment. Here BH is there, DF is there. Okay, you can choose a. So here write BH and CG. Identify any two line segments. So only take CG and BH. So you can take BH, then you can take CG, then you can take DF also. Okay, so here identify any two. So write only CG and BH. Okay, okay. Then D question, are these true? So first AC. A to C, how much? A to C, A to B 1 unit, B to Z again 1 unit. So A to C is 2 units. AC equal to 2 units. Okay, then FG. F to G is 1 unit. FG equals 1 unit. 1 unit. AC greater than FG. So answer is true. Okay, true. AC is greater than FG. Okay, then second one, CD equal to GH. CD how much? CD is C to D is 1 unit. Okay, 1 unit. Then G to H, GH is also 1 unit. So answer is true. True. Okay, hope all of you understood. Then next third one is BC less than EH. BC is BC 1 unit. BC 1 unit. Then E to H. E to H. E to F 1 unit. E to G 2 units. E to H 3 units. Okay. So answer is BZ less than EH. True. Okay. Hope all of you understood.
Triangles. Let us recall what is a triangle. A triangle is a polygon having 3 sides, namely AB, BC and CA, and 3 angles, angle A, angle B and angle C. Triangles can be classified on the basis of the sides. Look at this triangle ABC. All its sides are unequal. We call such a triangle as scalene triangle. Now look at this triangle. It has 2 equal sides. PQ equals to PR, but it is not equal to QR. So we call this triangle as isosceles triangle. Now let us look at this triangle LMN. All its sides are equal. LM equals to MN equals to LN. This is an equilateral triangle. We can also classify triangles on the basis of angles. Look at this triangle. Each of its angles is less than a right angle. That is, all the angles are acute angles. This triangle is known as an acute angled triangle. Now let us look at this triangle PQR. It has one angle as a right angle. So we call this triangle PQR as a right-angled triangle. Again, now look at the triangle LMN. The angle LMN is greater than a right angle. That is, it measures more than 90 degrees. It is an obtuse angle. So, a triangle which has one of the three angles as an obtuse angle is called an obtuse angled triangle.
Classification of triangles. A triangle is a closed figure with three sides. We can classify all triangles on the basis of their sides, angles. Let us look at them one by one. Classification by sides. Triangles are classified on the basis of their sides into equilateral triangles, isosceles triangles, scalene triangles. Triangles in which all the three sides are equal are known as equilateral triangles. All the angles of equilateral triangles are also equal. Triangles in which two sides are equal are known as isosceles triangles. The angles opposite to the equal sides of isosceles triangles are also equal. Triangles in which all the sides are unequal are known as scalene triangles. All the angles of scalene triangles are unequal. Classification by angles. The sum of the angles of a triangle is 180 degree. Triangles are classified on the basis of their angles into acute angled triangles, right-angled triangles, obtuse angled triangles. Triangles in which all the three angles measure less than 90 degree are known as acute angled triangles. Triangles in which any one angle measures exactly 90 degree are known as right-angled triangles. Triangles in which any one angle measures more than 90 degree are known as obtuse angled triangles.
And next exercise 5.6, first question. Okay, name the types of following triangles. So all of you know the different types of triangles. So triangles are classified on its sides and also classified on its angles. Okay, so you can check the types of triangles here. Okay, first a question. Triangle with the lengths of sides 7 cm, 8 cm and 9 cm. So as the triangle has three sides, all the three sides have unequal length or different measures. So which is the triangle? Is scalene triangle. Okay, hope all of you understood scalene triangle. So a triangle with three sides of unequal measure are called scalene triangle. Is called scalene triangle. Okay, then next B question. Triangle ABC with AB equal to 8.7 cm, AC equal to 7 cm and BC equal to 6 cm. So when you draw the triangle ABC, okay, so AB, A to B, okay, AB 8.7 cm, is BC 6 cm, AC 7 cm. So all are unequal measures. So this is also a scalene triangle. Scalene triangle. Okay, then next C question. Triangle PQR such that PQ equals QR equals PR equals 5 cm. So when you draw the triangle PQR, PQR, okay, PQ 5 cm, is QR 5 cm, is PR also 5 cm. So triangle having all its sides and angles are equal is called Yes, equilateral triangle. Okay, equilateral triangle. Okay, all of you carefully study the spelling of all the triangles. Okay, equilateral triangle. Then D question. Triangle DEF with measure of angle D equals 90 degrees. So how you read? Measure of angle D equals is 90 degree. So one angle is 90 degree. Then which type of triangle? Is right angled triangle. One angle is 90 degree. Then the triangle is a right angled triangle. Okay. Then next, triangle XYZ with measure of angle Y equals 90 degree. So it's a right angle. Okay. And XY equals YZ. So two sides are equal. Then is isosceles. Okay. Measure of angle. One angle is 90 degree and two sides are equal. So isosceles right angled triangle. Okay, right angled triangle. Isosceles right angled triangle. Then fifth question, triangle element with the measure of angle L. Okay, measure of angle L equals 30 degree. Measure of angle M equals 70 degree and measure of angle N equals 80 degree. Okay, so all the three angles are acute, less than 90 degree. So this triangle is acute angled triangle. Acute angled triangle. Hope all of you understood. Okay.
Polygon. Take 5 matchsticks and join each matchstick to each other by one end to other end. The figure we get is a polygon. Hence, we define a polygon as a closed plane figure with 3 or more line segments. The line segments forming a polygon are called its sides. The meeting point of a pair of sides is called its vertex. This polygon has 5 vertices, namely A, B, C, D and E. Any two sides with a common endpoint are called the adjacent sides of the polygon. For example, AB and BC are adjacent sides. The endpoints of same side of a polygon are called adjacent vertices. For example, A and B are adjacent vertices, whereas A and C are non-adjacent vertices. A diagonal of a polygon is a line segment joining the non-adjacent vertices of the polygon. Here in this figure, AC, BD, CE, AD and BE are diagonals. Some polygons with their number of sides are given here.
A polygon is a closed figure with 3 or more sides. Here are some polygons. Let us count their sides and name them.
Look at these figures. All these figures have 4 sides. These figures are called quadrilaterals. There are mainly 3 types of quadrilaterals, namely trapezium, parallelogram and kite. Parallelogram is further of 3 types, namely rectangle, rhombus and square. A trapezium is a quadrilateral in which one pair of opposite sides is parallel. A parallelogram is a quadrilateral in which opposite sides are parallel. Opposite sides are equal and opposite angles are equal. Also, its diagonals bisect each other. A rectangle is a parallelogram whose opposite sides are parallel and equal. All angles of a rectangle are right angles. Also, its diagonals bisect each other and are equal. A rhombus is a parallelogram whose adjacent sides are equal. Diagonals of a rhombus bisect each other at right angles. A square is a parallelogram whose all sides are equal and one angle is a right angle. Also, its diagonals bisect each other at right angles and are equal. A kite is a quadrilateral whose adjacent sides are equal and diagonals intersect at right angles.
Classification of quadrilaterals. Quadrilateral is a four-sided polygon. Quadrilaterals are classified as rectangle, square, parallelogram, rhombus, trapezium. Let us learn the properties of each. Rectangle. A rectangle is a quadrilateral whose opposite sides are equal and parallel, whose four angles are equal, whose each angle measures 90 degrees, whose diagonals are equal and perpendicular to each other. Square. A square is a quadrilateral whose four sides are equal, opposite sides are parallel, four angles are equal, each angle measures 90 degrees, diagonals are equal and perpendicular to each other. Parallelogram. A parallelogram is a quadrilateral whose opposite sides are equal and parallel, whose opposite angles are equal. Rhombus. A rhombus is a quadrilateral whose four sides are equal, opposite sides are parallel, opposite angles are equal, diagonals are perpendicular to each other. Trapezium. A trapezium is a quadrilateral whose opposite sides are parallel.
Three-dimensional shapes. In the earlier chapters, we have studied about plane or flat shapes which have only two dimensions, namely length and breadth. Now we will learn about three-dimensional shapes or solid shapes. A solid shape has length, breadth, and a third dimension, that is height. We live in a three-dimensional world. Every object we see or touch has three dimensions. For example, a book, dice, television, water bottle, and so on. Cube. Consider this 3D shape. This shape is called a cube. Examples of a cube are a Rubik cube, a dice, and sugar cubes. Each side of the cube is a flat surface called a face. Here we see that a cube has 6 faces. 2 faces meet at a line segment called an edge. There are 12 edges in a cube. 3 edges meet at a point called a vertex. Clearly, there are 8 vertices. Cuboid. This shape is called a cuboid. Examples of a cuboid are a pencil box, matchbox, gift box, and book. Same as in the case of a cube, a cuboid has 6 faces, 12 edges, and 8 vertices. Cylinder. This is a cylinder. Examples of cylindrical shapes are a deodorant bottle, a gas cylinder, a water bottle, and a wooden log. A cylinder has 2 circular faces, one at the top and other at the bottom, and a curved surface. Cone. This is a cone. Examples of cone are a birthday cap, an ice cream cone, and a tent. A cone has a circular base and one curved surface. Also, it has one vertex. Sphere. This is a sphere. A football, a golf ball, globe, and a basket of oranges all are spherical in shape. A sphere has no vertices, no edges, and no faces. Pyramid. Children, can you tell how a pyramid looks like? Recall the pyramids of Egypt. A pyramid is a shape with a single base and the other faces are triangles. For example, a square pyramid has 5 faces, 1 square face, base, and 4 triangular faces. It has 8 edges and 5 vertices. In a triangular pyramid, there are 4 triangular faces, 1 triangular face, base, and 3 other triangular faces. It has 6 edges and 4 vertices. Prism. A prism is a shape with 2 identical bases and the other faces are parallelograms. For example, a triangular prism has 5 faces, 2 triangular faces and 3 rectangular faces. It has 9 edges and 6 vertices. In a rectangular prism, there are 6 rectangular faces. It has 12 edges and 8 vertices.
Three-dimensional shapes have depth. They are not flat like two-dimensional shapes. Examples of three-dimensional shapes are cube, cone, sphere, cuboid, prism, pyramid, etc. The flat surfaces of a three-dimensional shape are known as its faces. The points where two faces meet are known as edges. The points where the edges meet are known as vertices. Let us look at the following three-dimensional shapes: cube and cuboid, triangular prism, square pyramid. Cube and cuboid. A cuboid has 6 faces, 12 edges, 8 vertices. An example of a cube is a dice. An example of a cuboid is a book. Triangular prism. A triangular prism has 2 triangular faces, 3 rectangular faces, 9 edges, 6 vertices. An example of a triangular prism is a tent. Square pyramid. A square pyramid has a square base, 1 square and 4 triangular faces, 8 edges, 5 vertices. An example of a square pyramid is the Egyptian pyramids.